You know how tech giants like Amazon and Netflix seem to update their applications constantly, almost every single day, without everything just grinding to a halt? Well, the secret behind that is a major architectural shift. We're going to dive into that whole transformation, starting from the old world of monoliths and moving into the modern era of microservices.
So, here's what we're going to cover. First, we'll start with the problem itself, the monolith. Then, we'll get into the solution, microservices. We'll look at how they talk to each other, explore the trade-offs because there are always trade-offs, and finally, we'll touch on a key decision you'll have to make when you're organizing all your code.
All right, let's kick things off with Section 1, the monolith problem. You see, to really appreciate why microservices are such a game changer, you first have to understand the pain and the problems they were designed to fix.
So, what exactly is a monolith? Well, picture an entire online store. I'm talking user accounts, the shopping cart, the product catalog, everything, all tangled up together in one massive codebase. Every single piece is developed, deployed, and scaled as one single unit. That, in a nutshell, is a monolithic architecture. And this approach? Well, it leads to some major headaches. A developer changes just one line of code in the payment feature, and boom, you have to rebuild, retest, and redeploy the entire application. And what if your shopping cart gets a huge traffic spike during a sale? You can't just scale that one part. Nope, you have to scale everything, which is super expensive and really inefficient. Over time, it just leads to tangled code and locks you into a single tech stack for the whole show. So yeah, things were getting pretty painful. Clearly, the industry needed a better way. And that brings us to our next section, enter microservices, which was the proposed answer to all those monolithic problems.
Microservices basically flip the entire script. Instead of one giant application, you build a suite of small, independent services. So that online store we talked about, it's no longer one giant block. It's now a collection of focused services. One for user accounts, another for the shopping cart, one for payments. You get the idea.
But here's the really crucial part. It's how you break it down. You don't just make a database service and a UI service. No, you organize around business functions. The user account service handles everything about users. The shopping cart service handles everything about carts. Each one is self-contained, does one job really well, and, this is the magic phrase, is loosely coupled. That means you can update the payment service without even touching, let alone breaking, any of the others. And when you put them side by side, the difference is just night and day. With a monolith, you deploy all at once. With microservices, you deploy services independently, whenever they're ready. You have to scale the whole monolith versus just the one tiny microservice that's actually busy. And here's a huge one. You can have dedicated, independent teams for each service, and they can even use different programming languages or tech stacks. That is a total game changer for innovation. Okay, so this all sounds amazing, right? But it brings up a really big question. How do all of these independent little services actually work together to create one smooth experience for the user? Let's get into the mechanics. Yeah, exactly this, right? If the checkout service is its own little world and the user account service is another little world, how on earth does the checkout service get the user's shipping address? Let's look at the most common ways they do this. Okay, method number one, and probably the one you'll see most often, is just using direct API calls. This is what we call synchronous communication, where one service makes a request and then just waits for a response before it moves on. It's actually pretty straightforward. Our checkout service sends a direct HTTP request to the user account services API, basically asking, hey, I need the address for user 123. The checkout service then has to hit pause and wait until the user account service sends that address back. It's simple, it's direct, and it's very, very common. But hang on, what if waiting isn't an option? What if you just want to fire off a message and get on with your work without waiting around? Well, that's where asynchronous communication comes in, and it often uses something called a message broker. Think of a message broker as like a digital post office for your services. When an order is placed, the checkout service doesn't call the notification service directly. Instead, it just drops off a message at the post office that says, hey, an order was placed for user 123. The broker then makes sure that message gets delivered to the notification service, which can pick it up and process it whenever it's ready. The services never even talk to each other. Now, for a more modern and, frankly, sophisticated approach, especially in really complex environments like those managed by Kubernetes, we have something called the service mesh. This idea is seriously powerful.
Imagine if instead of every single service having to worry about stuff like retries, security, and logging for all its communications, you could just offload all of that to a dedicated layer of infrastructure. That's what a service mesh does. It's like having a super smart assistant that handles all the complex communication logic for you, which frees up your developers to just focus on the business logic inside their service.
So, we've got all this amazing power and flexibility. But you knew there was a catch, right? There's always a catch. This new architecture solves a ton of old problems, but it absolutely introduces some brand new challenges of its own.
So let's look at the trade-off. On one hand, you get these incredible benefits: independent releases, the freedom to use the best tech for the job, autonomous teams, and super-targeted scalability. But the price you pay is a big increase in complexity. I mean, what happens if the user account service goes down right when the checkout service needs it? How do you get a clear, big-picture view of the health of hundreds of these tiny services? These are the new problems you have to solve.
Now, the good news is, while these challenges are totally real, we're not flying blind here. A really mature ecosystem of tools has grown up around this architecture. Things like Kubernetes are perfect for running and orchestrating these applications at scale, and companies like HashiCorp offer a whole stack of tools, like Consul for your service mesh and Vault for security, that are specifically designed to tame this new complexity.
All right, we're on the home stretch. Just one last, really important topic to cover. You've decided to go with microservices. Awesome. Now, where do you actually put the code? This brings us to a huge architectural debate: the monorepo versus the polyrepo.
First up, the monorepo. The idea here is pretty simple. You have one single giant code repository. And inside that one repo, you have a folder for the user service, a folder for the payment service, another for the shopping cart service, and so on. It's all in one place. And then you have the complete opposite, the polyrepo. Here, every single microservice gets its own dedicated, completely separate code repository. So you'd have a user service repo, a payment service repo, a whole bunch of different repositories that make up one single application.
So which one's better? Well, it's not that simple. The monorepo is definitely easier to start with, and sharing common code is a breeze. But you run the risk of your services getting too coupled together, and your build pipelines can get pretty tricky. The polyrepo, on the other hand, gives you really strong isolation and simple, straightforward pipelines. But trust me, managing dozens of repositories and sharing code between them can become a real headache. The general rule of thumb: a monorepo can be a great fit for smaller projects, while bigger organizations with separate teams often lean towards a polyrepo setup.
So, we've gone on quite a journey, haven't we? From the rigid constraints of the monolith to the incredible flexibility of microservices, we've looked at their core ideas, how they communicate, and the real-world trade-offs you have to make. So, the final question isn't just about which blueprint is right for your next project. It's about how you'll balance the power of this new architecture with the complexity it's guaranteed to introduce. What are you going to build, and what trade-offs will you choose to make along the way?